Okay, so we're going to be starting this chapter by talking about solving linear equations by graphing. Um, and a system of linear equations is simply a um, multiple linear equations in a single defined region. That goes with anything that's defined as a system. A system is simply multiple objects defined in the same structure or region, like the solar system or your circulatory system. We have multiple things working together in conjunction with each other. So here we have a couple equations, linear equations, working in conjunction with each other. And so here we have two equations generically defined in standard form. Now they don't have to be in standard form. They could be in slope-intercept form or point-slope form or no specific form at all. But anything that has two or more linear equations is going to be considered a system of linear equations. And we're going to learn how to solve those. So we're going to take a graphic approach in this section. So we're going to graph this system of linear equations. Now I'm going to take two different approaches here and show you two different ways in which you can graph them. The first one, I'm going to take the graph the 5x minus 2y equals negative 10 first. And the way I'm going to do that is I'm going to go ahead and put this into slope-intercept form. So let me rewrite this. This is 5x minus 2y equals negative 10. So I'm going to solve for y. I'm going to subtract 5x on both sides. Leaves us with negative 2y equals negative 5x minus 10. And then we divide both sides by negative 2. So y is equal to, now the negative 2 divides both into the negative 5 and the negative 10. So we'll be left with positive 5 halves x and plus 5. Okay, so we would graph this equation by starting at the y-intercept, 1, 2, 3, 4, 5, like so. So I'd put a point there. And then I'm going to go over to the right, up 5 and then over 2. So 1, 2, 3, 4, 5 over 2. And that's going to take me to the edge of my graph. I want to get at least 3 points in when using this method, so let me go work this one backwards, down 5 and then to the left 2. Okay, and we'll connect those. So I have one, goes like that. Alright, so accuracy does count for a lot when you're graphing, so make sure you're using a straight edge, make sure your points are right. It's critical that you have an accurate line when using this method of solving systems by graphing. Okay, now the other way we can graph this, since it is in standard form, we could also find the x and y intercepts. So for the second one, instead of converting it into slope-intercept form, I'm going to find it by using the intercepts. So I have 2x minus 4y is equal to 12. I'm going to start off and find the y-intercept by plugging 0 in for x. So I have 2 times 0 minus 4y equals 12. So that's negative 4y equals 12. And therefore, y is equal to, well, I'll divide both sides by negative 4. Negative 4. So y is equal to negative 3. So I'm going to have a a y-intercept of 0, -3. Get a little more space here to work with. Okay, so that'll be my first point. So 0, -3. Okay, so I got that one. And then I'm going to find the x-intercept. And I'll find that by plugging 0 in for y. So 2x minus 4 times 0 equals 12. So 2x is equal to 12. Divide by 2. And x is equal to 6. And so my next ordered pair is going to be 6, 0. And that's going to be my x-intercept. So I'm going to go to 6, 0, 1, 2, 3, 4, 5, 6. And just using those intercepts, I'll be able to make my next line. So again, accuracy counts. So I'm going to do absolute best at making this line go through those points. So let's see, it looks like it's fairly close, not perfect. It's a little hard to do it using this notepad that I'm using on the computer. It'll be easier to do it on paper. But it seems to me that the point of intersection is going to be located here at this. Now this is approximate given the inaccuracy of my graph, but it's crossing at -4, -5. And that's going to be the solution. Okay, so what does it mean to be a solution? It means that you can take this point of -4, -5 and plug it into the first equation and get a true statement. So you'd plug the, or substitute in the -4 and for the x, and you'd substitute the -5 and the y. You work that out, it should give you -10. And that's a solution. And the next one, we would substitute -4, -5 into that, and it should give you 12. Remember, any point, any ordered pair you plug in x and y into an equation is considered a solution if you come up with a true statement. So let's verify that this is in fact a solution. So I'm going to go ahead and substitute this point into the first equation. So I have 5 times -4 minus 2 times -5. It should give us -10. So this is going to give me -20 plus 10, and -10 equals -10. So that works. That's a solution to that particular equation, one of an infinite number of solutions. And this will test. So 2 times -4 minus 4 times -5 should equal 12. So that's going to give us -8 plus 20, and that gives us 12. So 12 equals 12. So that ordered pair, that point of -4, -5, works for both. And it is the only point that is going to work for both equations. Hence, that's the only point that's on both lines physically. So now that's not the only possibility. You could have just one solution like we did in that example. So we'd have a point where intersection. So remember, any point on these lines is a solution. But there's only one point that's on both. That if you substitute that ordered pair into both equations, it'll be true for both. And that will be the point of intersection. But let's say you graph it and you draw one line, and then when you draw the second line, it's right on top of the first line. It's the same line, which means there's an infinite number of solutions, which mean that there's an infinite number of points of intersection. Every point on here is a point of intersection, so we say there's infinitely many solutions. And finally, if the lines are parallel, there's no point that they share. Okay, you would have, one line here, and then we have another line, below it. Well, if, you know, by definition, parallel lines do not intersect, and we need a point of intersection to find a solution, then it's impossible. There is no point that you can substitute into both equations and it'll be true for both. It's impossible, hence no solution. Anyway, that is solving linear systems by graphing.